everyone. It's my great pleasure to be here with all of you and to introduce Jonas Riccardi, who is the CIBM Data Science section head, and he will be chairing the session today, and I leave it to you.
Thank you, Pina. So it's a great pleasure to be here today, to see many of you here in the room and online as well. And I'm happy to introduce Clara E today. So Clara, you see here, is a full professor and dean of research at Haute École de Santé in Geneva. And she also has a privat docent in the University of Geneva. So she works closely between the two institutions. And she has a very interesting, as you will see, dual background as both a professional musician, violinist, and neuroscience. She has a PhD from the University of Geneva in neuroscience. And what this allows her to do, you will see, I think, in this talk, is really work at this very interesting intersection of music and neuroscience. And for example, she looks at changes in brain structure and function with music expertise. And she looked as well as natural correlates of absolute pitch. So this kind of research that you'll see today. And so her work typically takes the form of rigorously designed and controlled randomized trials. So this is something that's also to be noted. It's not often the case that we have this really rigorous design for this neuroscience experiment. And that takes her across age ranges from very young to the elderly and across pathologies as well. For example, she's done work on mild cognitive impairment and also on clinically relevant outcomes like musculoskeletal pain. And so this focus on randomized controlled trials allows us to measure precisely the effect of music-based intervention onto cognitive and sensorimotor outcomes and to uncover the underlying neuroimaging phenotypes. And Clara is probably, for some of you, is somebody familiar. You've seen her work. She makes heavy use of neuroimaging, mostly MRI, but I've seen also some EEG in your work. And she's been collaborating with CIBM for some time. So she asked me a few years ago to come on board for a project that she would present some part of it. And I was very happy to join her and Damien Marie and Matthias Fliegel in psychology at University of Geneva for a very ambitious ongoing randomized clinical trial involving school children, which is funded also by the SNF. And as you'll see from Professor James' presentation, I think the intersection of domain expertise in psychology and music and state-of-the-art neuroimaging and novel methods in machine learning is a very promising combination to further our understanding of the brain. So thank you very much for agreeing to come visit us on very short notice. I have to say that she had very little notice of this talk. We might say this was allegro vivace, if I may. And I'm looking forward to listening to melodic talk with both ears. The floor is yours. Thank you.
Thank you, Jonas. Very happy to work with Jonas, and also I see Damien Marie on the screen, which is reassuring. So good morning. Clara James, violinist, psychologist, and neuroscientist. Which of course is a parcours that has strengths and weaknesses. I will present today how music practice promotes structural and functional brain plasticity across the lifespan, supporting cognitive, emotional, and sensorimotor development. This is of course not my image, but that of Gottfried Schlauch. At the heart of this talk is the nature-nurture question. Does training shape the brain, or do musicians start with a natural disposition? Now I'm talking about expert musicians, where my talk will start with, but to put it in a wider context, you can also formulate the question as follows: can music practice adapt brain and behavior? Early study in the 90s compared musicians and non-musicians and found obvious differences. This was then vividly criticized, because we can, of course, not tell by such group comparisons whether music practice was at the root of these changes. So after this elogious introduction by Jonas, I will start with a cross-sectional study, but a very special cross-sectional study. The problem is that becoming a professional musician takes at least 10 years of practice. That's kind of a rule of thumb. There's always exceptions. And that is, of course, a challenge to track in research, because you cannot follow people over 10 years. You don't know what they will do, and then you would have to start in childhood. So to study the impact of training, I conducted a cross-sectional study in young adults with rigorously matched groups for age, gender, age at beginning of training, very important if you compare amateurs and experts, fluid intelligence and education level. The groups were separated on the basis of training intensity and were significantly different around the age of 10 and beyond. So these people, 3 times 20, were put in the MRI scanner, and they heard rich polyphone musical stimuli that ended either regularly or on a expectation violation of 2 levels. We're all very satisfied. Who is satisfied? Who is not satisfied? Good. Now, this is not a dissonance, it's a cognitive error. You cannot end the music on this chord. I cannot go in details for the sake of time. And now the middle one. Yom, we have the third in the bass, and not yom, bom, bom. The first note, the root note of the scale. So this is a transgression. Now these stimuli perfectly separated the groups behaviorally for subtle T1 and apparent transgression. So this was the subtle transgression, this was the apparent transgression. We can really see that these stimuli did their job. And then, more interesting, we also found far transfer, with experts being superior for a 3-bar back visual working memory task that actually developed quadratically as a function of training intensity. If we look at the brain, we computed very specific contrasts, subtracting the brain responses to regular endings from those of the transgressions. Therefore, we focus exclusively on syntax transgression because let's say we regress the music out to some extent. And when we did that, so you see here the first one, so subtle transgressions and apparent transgressions, always with subtraction of the regular chords responses, we can see that as a function of expertise, non-musicians, amateurs, experts, in a right secondary auditory area, activation go up, which is logic. So we have a greater sensory sensibility in the experts. However, in a frontal, a cognitive network, we see the opposite effect for the apparent transgressions. And this really shows increased efficiency. And this is what I really call the double-edged sword of plasticity. But for me, the main result in the context of this talk are the gradual differences. Always the amateurs hold the middle position in whatever result we look at. And that is a clear indication that nurture at least plays some role. Now, we also did a voxel-based morphometry analysis, and we found gray matter differences related to expertise. In red, going up with expertise, in blue, going down. We can see that in sensory and cognitive areas, there's increase of gray matter, whereas in motor-related areas, in the basal ganglia and in sensorimotor areas, gray matter is going down. This suggests against enhanced processing versus greater efficiency. And both patterns again scaled with the level of expertise. And this repeated itself for white matter. We did complex analysis. I can answer questions afterwards, but now I will just tell you that we did a probabilistic fiber tracking, and in our population we identified 2 tracks, and this track going from, actually we used the seed areas, the results from the fMRI test, and we can see that in this yellow track there is increasing track consistency, so it's more clear cut, and this measure of track consistency is then linearly related to the D prime rating, so the rater sensitivity for the subtle and the apparent transgressions. So to wrap up, this fundamental research that was cross-sectional is the basis of my future research, because I could show that at least partially musical training contributes to these observed differences in all different domains. And therefore, musical training holds promise as a developmental tool and a therapeutic intervention. I just want to thank the people with whom I did that research. 2 of them are of the CIBM, and maybe Marcus also, I don't know, but you will all know him, those who are here for a longer time. Now we make a big skip and we go to a behavioral only study that I did between 2016 and 2018. Actually, it's thanks to Patrick Vulmier that I was invited to study the Orchestra in Class project in Geneva via a behavioral study. Half of the classes received intensive music training in a string orchestra, and the other half had the traditional music lessons. Nevertheless, both groups received 2 times 45 minutes of weekly musical instruction by professional musicians. So both groups were still trained using music. So data were collected at baseline after 1 and after 2 years. We focused on progress measures, subtracting the baseline scores from the scores after 1 and after 2 years of interventions. And we found close transfer effects for a musicality test that was developed by Gordon for tonal stimuli, rhythmical stimuli, and combined the combination actually of these 2. And we can see that there were superior scores for orchestra in class that were most pronounced after 2 full years. We used linear mixed models to do this analysis. And also sensorimotor skills that we evaluated with the Purdue-Packard test. Here, 3 simple ones where we can see that the summit of progress was already attained after 1 year. But a more complicated test, the assembly test, where you have to put together little elements with 2 hands, so fine motor coordination of both hands. There we can see that actually the development needed 2 full years to fully develop. Now, this is not astonishing. Much more astonishing was the fact that far transfer effects were found for working memory, sustained and focused attention with the D2 test, and even for abstract reasoning. And what is very interesting is that we can see that these developments over time are very similar. So we see really parallel development suggesting that there's interlinked maturation processes driven also by the interventions that this is supporting these results. And very important, slow build, strong impact. It took some time. It took 2 full years. After 1 year of intensive training, the results were not significant. We panicked at that moment, but then it turned out all right. Because after 2 years, there were really striking differences for these 2 basic executive functions and more complex reasoning. Now, again, a big jump to healthy elderly, before I will present the project that I'm actually doing together with Jonas, Damien-Marie, and others at the moment. We trained the brain with music in healthy elderly in Germany and Switzerland. Yes, so in this study, Dimitri van de Wiele and Damien-Marie importantly contributed to the study. And the rationale was the following issues that actually also hold later on when I talk about the children. I shouldn't go here, I should go there, it's fine. So first of all, music practice, I hope I have the time. I have a slide on that, but I have to see whether I can show you that. I already put in my abstract, looking back and looking forward. When you play music, it's online. So, okay, you are here and now, but you have all the time to look back in a small lapse of time and look forward in a small lapse of time to realize well what you're doing as a soloist, but even stronger so in a dynamic setting. These functions, of course, strongly decline with age, also sensorimotor integration. We already saw in preceding studies that we can improve cognitive function and well-being in older adults, but never was this paired with a full psychometric and MRI assessment. Very important, people have to like what they do, because it's the rewarding aspects of music that triggers neurochemical pathways that support intrinsic motivation and learning. Then in healthy and demented elderly, only listening attentive already yielded cognitive gains. And very important, the auditory system processes input the fastest. The P1 for visual stimuli is around 100 milliseconds after stimulus onset. For sounds, it's 50 milliseconds. It's really the most computational, rapid and intensive network of all sensory systems. And we presume that especially in a dynamic group setting, this ultra-fast information processing may drive the subcomponents of working memory update that is really the basic building brick of executive function, namely temporal sequencing and monitoring. It's this playing around the moment zero, what I just said, looking back and looking forward. I'm a professional musician. It's something I lived on a daily basis. You're all the time, am I with my neighbor? Am I wrong? Is my neighbor wrong? Am I with the conductor? All the projecting and looking back in order to function properly in such a setting. So we did the stratified RCT. We controlled for some factors, and we looked whether we could maybe countervail age-related cognitive decline. The protocol was published. So we had 150 healthy, musically naive older adults, half in Geneva and half in Hanover in Germany. And they were randomized into two groups. Piano practice was done with two students and a teacher. And the musical culture, that was actually something like sensitization to music, was done in bigger groups. We tried to align as much as possible the two trainings. In both cases, we used very musical stimuli to make sure that people liked what they were doing so that they could choose their favorite music, if possible. And there was, of course, the practical part that was the big difference, because the pianists really learned to play polyphone music with both hands. They learned to read scores and to improvise. Whereas the culture group that was also very strongly stimulated, it was originally seen as a control group, but it turned out to be rather a secondary experimental group. So they did, at the center of their activity, there was analytical listening, but they also learned a lot about music. So there was also a cognitive and semantic aspect about it. They had weekly lessons for 12 months and homework. And we assessed cognitive, music, and sensorimotor capacities, MRI of 5 types, and blood sampling. Here is the planning of the assessment. So baseline, 6 months, 12 months, and we also took delayed measures. And I would like to thank the BBL staff for the great help with this study. Better than a lot of words is this 1-minute excerpt from a course that was actually that's actually part of a report by the RTS that you can find here if you want to look at the whole reportage. No? Come on.
Les cours se donnent avec 2 élèves qui apprennent ainsi à coordonner leur jeu. Le piano permet d'exercer des capacités cognitives indispensables au quotidien, comme la mémoire et l'attention. Il sollicite aussi fortement la motricité fine.
Ce que je trouve difficile, c'est de coordonner les 2 mains. Il y a souvent un décalage ou une difficulté à articuler la main gauche et la main droite en même temps. Ça me surprend. Je crois que je ne suis pas trop malhabile de mes mains, en général, mais là, ça m'énerve et je veux y arriver.
On ressent une motivation, hein, c'est vraiment
Je vais faire le staccato encore plus, allez-y, encore plus piqué que ça, hein, vraiment.
D'autres groupes apprennent à mieux écouter la musique, sans jamais jouer d'instrument. Les effets de ces différentes approches sur le cerveau seront ensuite comparés.
Alors les commentaires, évidemment, je ne suis pas responsable, mais ça montre mieux ce qu'ils ont fait que beaucoup de mots. Oh, sorry, wrong language. Yeah, that was the pop-up because the video was in French. So now some selected results after 6 months. We were very lucky. We found a lot of things. I just present some important findings. The first concerns gray matter volume changes over 6 months. This is work done by Dr. Damien Marie, with whom I have been intensively collaborating on this project. And frankly, without him, I could not have brought it to a good ending. Now, first there was a disappointment using voxel-based morphometry. We found no group differences. And then we decided to pool the data. So piano and culture group together. And when we did that, we found relatively strong increase of gray matter in 3 different areas. Now you can say that we don't know whether it was due to the courses, but in general, at this age, there's a lot of data that showed that already in 6 months, there's really decline all over the brain. And there was decline all over the brain, interestingly, as you can see in the title, despite general brain atrophy, but not in these areas. So left caudate, linked to goal-directed behavior, right rolandic operculum involved in motor-related processing on the right side of the brain, apparently on the left side of the brain for language. And we observed bilateral increases in the posterior cerebellum, likely supporting enhanced advanced auditory perception and working memory. And as we also had a working memory task in scanner, we wanted to know whether maybe there was a relationship between this increase and the results in our working memory task. Working memory task was very simple. In the scanner, people had to compare 2 simple tone patterns and say whether they were identical or not. So true. With respect to the first pattern, false. So it was really very basic. And we found that working memory improved by 6% over 6 months. And this is, of course, a clear effect of near transfer. You learn music, you get better in tonal working memory. And this gain correlated effectively with cerebellar gray matter increase, but also with number of lessons, homework, and finally, sleep duration. And together, these 4 variables explained 70% of the variance, of which the major part was due to our interventions, so homework and number of courses. And then we went to look at white matter, or actually Christine Junemann, our German PhD student, she studied this using voxel-based morphometry. That's a sub-voxel analysis of white matter density. Well, you can derive different measures from that, but we used the measure of microstructural fiber density, and we found a group time interaction in the body of the fornix. We can see here the fornix also with this color-coded orientations in a whole brain. And actually, what is interesting, this fornix, this little white matter tract, here's the body, connects both hippocampi, and therefore is probably important for memory. Of course, with the interaction, we didn't know where it came from, but when we did contrast, it was clear that it was the piano group that was stabilized, whereas the musical culture group digressed, showed attrition. We dare to interpret this as a positive result of our interventions, which is, of course, something that we can discuss about. But again, normally, at this age, in 6 months, white matter decreases all over the brain. Interestingly, the fornix is a biomarker of aging, and so it was really shown here that actually, if you make music, your brain ages more slower. And we wanted to know whether it was maybe related to verbal memory, because we had a verbal memory test in our battery. And yes, actually, average time weekly spent on homework was linearly related to this fiber density change over 6 months in the body of the fornix. Actually, this is the mean weekly time of homework residuals, because we did non-parametric partial correlations. And you can see there's a linear relationship for the piano group only. Interestingly, when we pooled both groups, we finally found what we hoped to find only for the piano group, which is a linear relationship between these voxels in the body of the fornix and verbal memory scores. And actually, we can see that the subgroup that we don't see here, a subgroup of the culture group also benefited apparently from these lessons, in the sense that it increased or stabilized white matter density. Now, I show 1 results over the full period. We still have like 10 years of analysis to do with Damien, but for the moment, this is the last result I show you on elderly, and then we will move to young children. So we also measured resting state fMRI, and we see here the results after 12 months. We had several results. I will just concentrate on one because it's really very apparent and clearly to explain. So what we found is, again, interaction between the two groups concerning functional connectivity between the right motor hand area, big area that controls the left hand, and a whole panoply, to talk good English, of bilateral motor-related areas. So here was interaction, and again, of course, we wanted to know the orientation, and actually this was driven by the piano group only. So in the piano group, there was a stronger increase in functional connectivity over 6 months between the area that controls the left hand and these bilateral motor-related areas. Why the left hand? Well, in normal life, these were of course all right-handers, as in all brain studies. In normal life, we do a lot of fine-tune things with our right hand, but rarely with our left hand. These people never played the piano. For the first time in their life, they learned to have independent finger movement and coordinate both hands. So it's really very plausible what we saw here. And then we hoped it would be related to behavior, and it turned out so. Again, this Purdue pegboard that I already showed in the children's studies, and we found that the difference over 6 months in the score for this complex bimanual coordination task related linear to functional connectivity change also over, did I say 6 months? Over 12 months, both over 12 months, of course. And that was really nice. And when you're older, you really need that now with all these tablets and telephones, and in general, they lose in manual dexterity, but here they gained. How am I time-wise? I can show just 1 minute. Won't show the first one. Let's just show the same gentleman we just saw in the video after 3 months of training, only 3 months. He never played the piano. He wanted to play the piano all his life. Of course, but nevertheless. The carrier will go into syncopation, which is very different. And our jazz man, to show we really had taken into account the personal preferences of our participants. He already uses the to show that they learned something. And to wrap up, piano practice is particularly associated with, I didn't show that actually, I took that slide out yesterday because it was too long, improved speech and noise, but believe me, improved speech and noise perception, stabilization of white matter connectivity in the fornix linked to a training intensity and verbal memory, increased functional connectivity between the left hand area and bilateral motor regions, supporting fine motor skills. We also showed increased cognitive flexibility, and we have a paper that is now in second review in the Annals of the New York Times, where we could show increased well-being in the piano group at the delayed measures. And that's the study by Damien Marie. Both study of musical training were associated with improved work memory supported by cerebellar gray matter, training intensity and sleep quality, and also improved speech and noise perception that was bigger in the pianists. So with that, I really thank the team. Both Professor Eckhart Altemann and myself were also professional musicians, which helped a lot. And again, Dimitri was there. Damien, of course, he's my right and my left hand, and 2 students that did their PhD and 2 students who did their master in our team. Okay, now we get to what maybe interests you most, which is our new ongoing study that is a collaboration between the UNIGE, FAPSE and CIBM, Juvenile and HSSO. So I'm actually, many people don't know that these schools exist, but so I work in the Haute École de Santé de Genève, or if you want, at the University of Applied Sciences and Arts Health Department in Geneva. And many people don't know that there's any research going on there, but it is. And we have actually like 6 ongoing national funds, which is of course modest, but for such a small institution, not bad at all. We also have a European project and several Swiss. Okay, so so the protocol is published. You just have to type in DOI, and let me show you the experimental plan. So 3 experimental conditions. Orchestra in class, again, it's the same Academia d'Archi that also provided the lessons for my former study. And actually, it was these results that allowed me to get this national funding for this project, because we said what is lacking is younger children and neuroimaging, multimodal neuroimaging, and a much broader battery, which is what we did. So we have orchestra in class, but there's a lot of data on music being superior to drive executive function and development in general in children, also well-being. And this is all very interesting, but if you don't compare it to another art form that is just as intensive and just as well done and rich, then you're never sure whether it's typically this music instructions that make the difference. So interestingly, they play 4 different string instruments. Visual arts, many strands, not just drawing or painting or whatever, they do all kinds of different things. And we have an active control group that has a cultural outing every 2 months. So the frequency of the lessons is 90 minutes per week. So that's an intensive session in a group size of around 15 children. We have now 3 groups of 15 for each experimental condition. And we encourage them strongly to do some homework, but we cannot oblige them, but most of them do. And here is again Damien's way of very nicely representing the experimental plan, where we see that we gathered the data at baseline 12 months. Well, that was done. This is ongoing for the first group and will be done for the 2 next groups in 4 months. And at the end, after 2 full years, this will repeat. What do we measure? We have an extensive demographic battery with many information about whether they have siblings, the level of education of the parents, whether also we look also at screen time, many different things, and a comprehensive executive function battery that is enriched by data on emotional regulation. Emotional regulation is how well you can control yourself, your emotions, and this is known to be very important for executive function. If you're very out of balance on the emotional level, you cannot perform well at the cognitive level either. So we put that into the battery, and then we take 4 different types of memory measures. First, we did it in 1 session, and then after the first session with 15 children, we cut it in 2 because they're too young to stay in the scanner for 45 minutes. So now we cut it in 2 times 40 minutes with much more relaxed and much more time to explain things. Okay, and we also have different kinds of progress measures to see whether effectively these interventions, 1 and 2, do show progress. So we take videos every 3 months, we take photos of the artworks, the teachers rate the progress of the children on different Likert scales, and we also have access to the school results, which is quite exceptional. So what are our aims and objectives? So the final aim is to build, and that's why I work with Jonas, of course, an artificial intelligence model of typical executive function and brain development in children that are at start between 6 and 8 and at the end between 8 and 10. So it's a, let's say, shifting time window of age, considering differential effects in the context of that framework of orchestra in class visual arts versus the standard curriculum, the control group. And our primary objective is to enhance this basic building block of cognition, which is working memory, and its relation to brain plasticity, with our presumption that may turn out not correct, that there will be stronger effects for orchestra in class of our visual arts than for control. But I think for some aspects, maybe not for working memory, visual arts may be the better bet. Secondary objectives, more wider, not just working memory, but enhance executive functions and brain development through artistic inventions. Then what we also want to look at is whether working memory plays a central role in this data-driven model for executive function and brain development. Of course, again, the differential effect of artistic enrichment within the framework of this model. And finally, we hope to unravel to some extent the developmental transformation in the structure of executive functions. When children are really young, below 6 years of age, working memory, inhibition, and cognitive flexibility, which are like the basic bricks of executive functions, they are like one node. There's not really clearly one aspect that represents working memory and another that represents inhibition, for instance. It's all a little bit put together. It's one unit that functions, and progressively, apparently between 6 and 8 years of age, these three capacities dissociate. There's some literature that says it's first working memory, others that say it's first inhibition, but we hope, because we have this shifting time window, that we will be able to unravel this mystery that is still occupying a lot of psychologists. And then we can also underpin that with brain data. Here's our behavioral battery. I won't annoy you with that. I made a simple, child-friendly way of presenting this. Most tests are language-free. Of course, not the first one I present, it's always the same thing. The first one is working memory with the classical digits one backwards. Then we have a test, just like in the elderly, where the children have to compare 2 tones and 3 tones and tell whether the pattern is identical or different. Then we have a visual working memory task with a 1-back and a 2-back task, where the children have to discover little monsters that hide. And this was developed by our team. This one was borrowed in the literature. We also, to give an potential advantage to the visual arts group, look at spatial visual praxis with the blocks test. Then we have 2 tests on attention. One is more on processing speed, where you have to tap as quickly as you can when you see the witch. Here we have an adaptation of the D2 test, where you had normally you had to stripe letters with signs, but here you have just to take the doggy with the tail that goes upwards as quickly as possible. And next time it will be other animals. Then we have inhibition task, a motor inhibition task, go, no go, a more complex cognitive inhibition test, the flanker test that we adapted, or this adaptation already exists with little fishes, so we call it a fishing game. Then we have flexibility test. You have to find the blue or green dragon. The crux about flexibility is that you have one instruction and another instructions. First, you train them separately. You have to find the green dragon and tap when it's in the right spot. Or here you have to find all the objects that are red, and then the next one is all the objects that are blue, or you have to find the other dragon, and then it's intermingled. So you have to switch instructions very quickly, and that is something that is, in my point of view, highly implicated in musical practice, just like working memory, all these online things. And then we go one step higher to faculties that we can classify as being abstract thinking, the balance, and matrix test. And here we see, of course, the most simple item that we can imagine. Here's our MRI battery with gray matter and white matter assessment, task-related brain activity with a auditory tonal memory task and a visual working memory task, the MBAC that I just showed. And we also recorded resting state brain activity. I can tell you that the recruitment was a hell of a job. For around 4 months, although I have already all my staff sitting, taking their desks in their offices, we didn't have enough children. And then I was very direct, as Dutch people are, and I called the director of the SEE, Service de l'Enseignement de l'Éducation, who by mere chance had a doctorate in psychology. And I managed to convince her, and then she said, okay. First she said no, and then she called me back, she said, okay, I opened the whole canton. You can contact all the cantons. And personally, we made 200,000 flyers and sent them. I went with a chariot to the post office to send all these flyers, and we had 734 families who contacted us. And the result, I will not go in detail for time lag, is that we now have around 44 children in each group. First, we were very lucky because our aim was to have 15, but as always, oh, there's an L missing here. As always, you then still lose a couple of children. But we're good with around 44 or 40 children in each group, a little bit by sheer coincidence in the visual arts group. And now just a little word on the work of Jonas and Alessio in the context of this study. So Jonas accepted to work with us on this question of how to develop this model. The medal will come later. And Alessio is his PhD student, and to some extent also mine. as I pay him. He is now working on T0 data to try and already find the dynamics between behavioral data and brain data. And one of the first things that he would like to look into this enigma when this node of executive functions in very young children dissociates into inhibition, working memory, and cognitive flexibility. That's the first thing. So pinpoint when age and executive function scores lose predictive value for working memory, then to understand why. This is a slide that slightly changed, but it's all coming from Alessio and Jonas. And so it's our main aim to build this model of typical AF and brain development. This model does not exist. This, let's say, intertwined development of cognitive function, also emotional regulation and brain development. All the same, also within the context of this model, considering differential effects of OC versus VA versus the standard curriculum that is represented by the control group. The engineering question is, because we will part on connectivity, both structural and functional, and the first thing we would like to know is it an advantage to combine structural and functional connectivity to predict in the end cognitive scores, and to also model the pathway from cognitive scores to structural and functional connectivity. And also then, of course, what are the best deep learning architectural adaptations we need to develop in this case, but I leave that to Jonas and Alessio. So here, a slide that shows what we're now doing at baseline, or what Alessio and Jonas are doing at baseline. So first, as a feed-forward model from the phenotype that can be a cognitive score, but it can also be, for instance, age, or some demographics, or the fact that the child is bilingual. And then we will nourish the topological, one syllable too much, properties, which is actually an abstract representation of a network. And then this will, in a feed-forward model, create first synthetic data and then be trained on existing data. It's already done now with open source data, but for the data of our research, that will be a later stage. And we hope then, by means of this model, to be able to predict on the individual level the phenotype of the child. When we will turn the model on existing data, we get, of course, refinement of these structural and functional matrices and their influence on the phenotype by these loops that we can see here. So this is excitatory and this is inhibitory effects in those big population of neurons. Now, reality, end of data collection, August 2026. So we're very, very tense to keep the children in the game. So we have working with these very complex data analysis, but at the same time, we have to fidelize these children, talk to the parents. I go there all the time. I try to convince parents to come to the MRI, and they say once, "Oh, sorry, I'm shopping. I forgot to come to the brain and behavior laboratory." And then you would like to say, "Well, what the hell? But you cannot do that because we need these people." So that is really a big challenge, and I understand you want to work also in development, and both recruitment and this fidelization aspect is very important. And with that, I thank my scientific team, especially Damien. Again, he's my right and my left hand, and I couldn't do it without him. Interesting, we have really highly professionally schooled artists that conceived actually the lessons. They don't give them, but they conceive them. Here's one of the teachers who's also very implicated. We have Carol, who's also from the CIBM. Gian Vito is a psychologist, and he's actually a postdoc of Matthias Kliegel, our research coordinator. Alessio, of whom I just showed some work. Two fantastic master students that actually almost did a PhD thesis, and that will defend that soon. Two new students in neuroscience, and students at the bachelor and at the master level in psychology. And with that, I thank you for your attention.